Hello once again! Welcome to Gillesania Engineering Videos, your daily supply of solutions to engineering problems. Again, if you like what you see, please don't forget to hit the subscribe button. Or, to those who are planning to have their review in preparation for the board exam, or kahit undergraduate pa kayo, gusto nyo ng additional knowledge, you can join our GERTC Review Live. So that is, this will tell you about our review, a 13-week review at the palm of your hand at only 499 pesos a month. So you can subscribe for 1 month only or 2 months. It's up to you. It's up to you kung ano yung gusto. You can pay through GCash or credit card or any other medium. Just click the join button here. At first, you have to sign in with your email, of course. And then just click on this join button and then ayan, you're ready to go. Alright? Okay. Alright, in this video, we will have the second part of our pipes series. So, yung first part natin, I have solved 2 problems. So, let's continue with that. So, this is about pipes, laminar, and turbulent flow. So, we have here a sample problem. Oil of absolute viscosity mu equals 0.101 Pascal second and specific gravity of 0.85 flows through a 3,200 meter of 300 mm pipe of cast iron pipe at the rate of 0.045 cubic meter per second. What is the head loss in the pipe? What is the head loss? Again, tingnan natin kung paano natin malaman. I know you are thinking, what is the value of F? So, here we have to know if the flow is laminar or turbulent. So, ito yung given natin, no? Dynamic viscosity. Dynamic yung binigay. So, we need the rho here. Of course, we will assume that the rho of water is 1,000 kilograms per cubic meter. Ito yung specific gravity ng oil, binigay yan. The length of the pipe, the diameter in meter is 0.3, and the discharge is 0.045. Of course, we need this one, the density of oil. That is the product of the density of water and the specific gravity. So, that's 850 kilograms per cubic meter. So, kung gusto mong makuha mo na yung dynamic para mas magandang gamitin kasi yung dynamic viscosity. So, nu is equal to mu divided by the density. Of course, oil yan. Density of oil. The unit now is a square meter per second. Okay? So, para malaman natin yung flow, kung laminar or turbulent, para malaman natin yung F din, kunin natin yung Reynolds number. Reynolds number is equal to velocity. Okay? By the way, before that, solving ko muna yung velocity of flow. Velocity is equal to Q divided by the area of flow. The area is pi divided by 4 times d squared. By the way, yung hindi nakapanood ng part 1, part 2 naman kasi ito, I am using a math card here. So live ito. Ang kagandahan nito, pwede tayong what if mamaya. What if kung yung flow, increase natin yung flow, tingnan natin kung maging turbulensya, ano yung mangyayari sa head loss niya. Okay? Ito yung maganda sa live na solution using math card. Okay, so velocity is 0.63662 meter per second. Then, makukuha ko na yung Reynolds number, Rn, equals velocity times the diameter divided by the kinematic viscosity. Okay, so this is less than 2,000. 1607, less than 2,300. So this is laminar. And if that is laminar flow, the friction factor kapag laminar flow is equal to 64 divided by the Reynolds number. Okay, 0.03982. Then knowing that, masosolve na natin yung ating tawag dyan. Head loss due to friction. The formula is equal to F times the length of the pipe divided by the diameter times velocity head, V squared divided by 2 times G. Okay. 8.77. 8.776. Ayos ba? Alright. Now, you might ask me, sir, pwede gamitin yung 0.0826? Okay, so I know you are very familiar with this. Darcy Wisbach. Okay, this is correct. You can use that one. HF, sorry. Hindi nag-respond agad. HF is equal to 0.08263. Actually, that's the more accurate value, no? 0.08263 times F times L. Pwede yan. Times Q squared divided by diameter raised to 5. But, kasi gumagamit ako ng math I cannot use this one kasi may unit ako. If I will do that, iba yung unit na lalabas niya. Iba yung unit na lalabas, na? It will not be consistent. Okay, makakaroon tayo ng trouble. Wag na lang muna. Wag na lang nating, kasi kung gamitin ko yan, example na lang, ano? Iba. Square meter per second. Kasi yung, ano ba yung 0.0623? Pero dahil, kung value lang, okay na yung value niya. Pero bakit ganun yung unit? Kasi ang actual kasi, from here, explain ko sa inyo ha. Yung velocity head kasi, velocity head, kapag circular ang pipe, di ba? Okay, velocity is Q over area. Q divided by area. Ang area naman ay pi over 4. Pi divided by 4 times diameter squared. That is your velocity. Tapos i-square natin. Tapos i-divide natin siya ng 2G. Medyo mahaba-haba. So in terms of velocity head, that will become, pag sinimplify mo yan, magiging 8 times Q squared. Q squared divided by pi squared times G times diameter raised to the 4th power. Ito yung equivalent ng velocity head in terms of discharge. In terms of discharge. Kaya pag inilagay mo yung value na yan dito sa formula, HF equals dito. Tapos ito siya, palitan mo ng ganito. Ayan. Ha? Ayan. Tignan mo yung result niya. Yan, ayan. Meter na siya. Okay, you might have seen this in my book. Okay, ito yung normal ko na ano siya? Okay. 8 times F times length of pipe times Q squared divided by pi squared times G times diameter raised to the 5th power. Pwedeng ganon. Ang kainaman ng formulang ito, kasi ito, kahit anong unit, pwede. Kahit anong unit, pwede ito. Kasi yung 0.0826 na nakuha, itong value na yan, ito yung value ng 8 divided by pi squared. Pansinin nyo, 8 divided by pi squared times G. Yan, yan. 0.0826. Isa natin ang ano. 8265. 8265 nga. No, not 8263. 8265. Yan yung value niya. So, itong formula na to, magagamit nyo lang to kapag SI. SI, meter yung unit mo. Kapag feet, do not use this one. If you're using feet, then you go to this. Kasi ito, kahit anong unit. By the way, ID pala, ang ginamit pala natin dito, 9.81. Kaya pala ganun, 8263. 9.81. 9.81. Pero kung gusto mo ng mas accurate na unit, yan, G. Yung talagang G na hindi ni-round off. Yan yung value niya. 8266. 0.08266. Itong 8263 base yan sa G na 9.81. Okay, I hope you you get the difference of these two formulas, ha? So, okay din to. Kasi kung nagma-manual calculation ka lang, wala namang unit. Sa MathCAD kasi may unit, and I usually include units in my calculation. Because that will also guide me kung may mali yung mga formula ko, lalabas yan error. Error yung unit. Kaya I always use the unit. Kaya dito sa MathCAD, I will always use this formula para mas generalize siya. Okay. Now, you might also ask me, Sir, how about this formula? 128 times mu times L times Q. Okay, I know some of you nakita to sa libro. Okay, so pi times rho, in this case the rho of oil, and then times G times D. Actually, pwede rin to. Anyway, kung tingnan natin yung result niya, no? Pareho lang. Sorry, D raised to the 4th power. That's squared. Okay, 8.776. Actually, ganun din naman yan. Ang nangyari lang dito, kinumbine lang natin dito sa formula na to, and then your F is equal to 64 over Rn. And your Rn is equal to VD rho over mu. Kaya meron kang 64 times 8. Tapos, divided by 64 over Rn. Okay, yun. 64 times something like yung F mo ginamit 64 over Rn, and this becomes pareho lang naman yung unit. Alright, so that's it, ang ating value ng head loss. So again, Reynolds number less than 2,000, it's a laminar flow. The friction factor is 64 over Rn. You can solve for F, or if you want a direct solution, you can use this one. And again, velocity head, for the head loss, Darcy-Weisbach, pwede mong gamitin yan. In this formula, this is only SI. Or if you are using feet, then much better if you will stick to this formula. And if you want your velocity head to be expressed in terms of discharge, ito naman yun, velocity head in terms of discharge. 8Q squared divided by pi squared G. So that the head loss in terms of Q, ito na yung ating magiging format. So I know you are... Do not memorize the formulas. Mahirap yung gawin. I-memorize niyo yung formula. Okay? Now, what will happen if your, halimbawa, yung discharge natin lalaki? Hindi siya magiging 0.1. Pansinin nyo, lumaki na yung Reynolds number. So, most likely, turbulent flow na yan. So, if that will happen, and if this is turbulent flow, unless yung problem sinabi, assume laminar flow pa rin. Assume laminar flow. Well, if that is the case, then this is still acceptable kung laminar ang flow. Pero kung turbulent flow na yan, this is no longer acceptable. So, ano yung value ng F in this case? Okay, pag-usapan natin. Purahin ko muna yung result, ha? Alright. Okay, I change it to 0.2. What if the discharge is 0.2 cubic meter per second? The Reynolds number is already 7,000 plus. So, what if kung hindi na yan laminar? What if kung turbulent? So, meaning this formula here is no longer valid. So, to solve for the head loss, we will use the Colebrook equation. Ito talaga yung pinaka-main formula. I have here a Wikipedia information regarding the Colebrook equation. Ito yun. Ito yung Colebrook equation. So, the phenomenological Colebrook-White equation or Colebrook equation express the Darcy friction factor F as a function of Reynolds number and the pipe relative roughness. Okay, ito yung formula natin. 1 over square root of F is equal to negative 2 log of epsilon is the absolute roughness, and then 3.7 dH plus 2.51 divided by RE square root of F. Yung RE natin, ito yung ating Reynolds number, which I used Rn. Okay, meron ding ibang format nito in terms of the hydraulic radius. In terms of the hydraulic radius, RH. hydraulic reduce. Now, as you can see, matagal na itong formulang to, early 19th century. Kaya itong formulang to ay napakahirap solvin ang F. Kaya maraming mga other scientists following him that made an approximation of Colebrook equation. One very famous is Hallan. So as you can see here, explicit na yung F. Yung ating friction factor is expressed in terms of, pwede mo na masolve yung F. Marami to, Swami, Jains, and so on and so forth. Para natin basahin, 1983 pa to, Hallan. Proposed in 1983. Medyo hindi pa masyado matagal. Marami pang researchers but based on Colebrook talaga. Okay? But that was unfortunate before. But fortunately ngayon, kayang-kaya itong masolve using our calculator. The sheet solve, kayang-kaya itong masolve. Sheet solve, wala na. In fact, if you have heard about the Moody diagram, ito yung Moody diagram, base yan sa Colebrook equation. Have you seen the Moody diagram? Ito yun. Ito yung Moody chart. Moody chart. So, this is based from Colebrook equation. So, that was, yun na nga, sinabi ko before na mahirap pa yung pag-solve ng F. But ngayon, with the programmable calculator, that is not a problem anymore. Okay, dito lang, meron tayong roughness, epsilon. Ano ba yung roughness na yan? Anyway, constant naman yan, depende sa pipe mo. I have here values of epsilon, depende sa pipes. Okay, halimbawa, glass, 0.00115. Ito yung irregularity ng pipe. Kasi kung titinan mo yung pipe, you will magnify the inner walls of the pipe. Merong mga irregularities yan. Kahit glass, meron yan. The height of that in mm, yan yung ating absolute roughness. Absolute roughness. Alright? So, okay, in this case, this is cast iron pipe. Cast iron, 0.26 mm. Let's use this one. Let's use this one for the purpose of illustration. Let's use that value. Epsilon. We call this absolute roughness. Epsilon is equal to 0.26 mm. So, kaya to masolve. You can, I know you know how to use shift solve. Kayang-kaya to ng shift solve. Dito sa MathCAD, iba lang yung gagamitin ko. Ang pinaka-shift solve dito kasi meron tayong solve block. Okay, block solver. So, mag-assume ako ng value ng F muna. Let's say, assume ako ng 0.01. Ilalagay ko yung equation which is this. Lahat naman ito known na except for the value of F. And then, ito na yung pinaka-shift solve natin. F equals find F. Okay, so I will not show na lang how to use calculator for this, but you know that already. Okay, alam nyo na yan. Ayun lumabas na F. 0.03596. 0.26 yung epsilon natin. Dapat ang E natin dito gamitin yung mm. To be, pwede naman meter. Pwede naman mm by the way, as long as your D is also in mm. Para cancel yung unit. So, pwedeng mm na lang or diameter kaya. Alright? So, pwedeng gamitan yan. Pakita ko lang siguro. Alright. Ito, subukan natin, Subukan natin. So, we have 1 divided by the square root of f, x. Equals, negative 2 log of the quantity epsilon. Ano yung epsilon natin? 0.26. Ano ba yung diameter natin? Diameter is, 300. Okay, so 0.26. I'm sorry, medyo babagal ako. 0.26 mm divided by diameter 300 over 3.7. 3.7 and then plus 2.81 divided by Rn. Ano yung Rn natin? Huwag mo natin sa taas. Rn natin 7143. Ilagay natin dito para madali natin makita. Alright. 7143.588. Five-line na lang. Times the square root of f, which is x. Okay, sana wala akong error. Close parenthesis. Wala bang... Tama naman siguro. Kadalawang beses ako nag-parenthesis. Dali. 2 lang. So, oops, up. Dapat mag-close pa ako ng isa. Doble yung parenthesis natin. Ilan? Para hindi mag-error. Okay. And then, shift solve. Okay, we can put an initial value or, okay, 0.01. Okay, done. 0.03596. So, no problem at all. No problem at all. Isipin mo, sa panahon nila noon, wala pang computer, kaya ang daming approximation. Mahirap yung buhay nila before. Ngayon, napakadali. Ito yung F na gagamitin natin here. So, your F will now be that one. Then, you can now easily solve. You cannot use this one. Kasi ang assumption dito is laminar flow. So, let's go back to this talaga. Ito yung pinaka main formula natin. So, 156. As compared to nakuha natin dito na 39 lang. Assuming laminar flow. Ito, turbulent flow. Okay? So, alright. So, yan yung ating head loss in pipe. Laminar and turbulent flow. Okay? So, I hope you learned a lot from this video. Okay, we will have part 3 after this. No, stop ko muna. Medyo mahaba na. So, magpa-part 3 tayo. Continue pa rin tayo with pipes. Okay? So, thank you so much. And please don't forget to subscribe sa channel natin. Or, if you want the full review sessions namin, you can subscribe to our GRTC Lite at 499 pesos monthly subscription. Thank you so much for watching.